Alright guys, here's the video for number 2b on the half angle identity page in our packet. I wrote out the problem, sine x over 2 plus cosine x minus 1 equals 0. And the first thing is that sine x over 2, I want to throw in the half angle identity there, which is our 1 minus cosine x over 2. I'm going to move everything else to the other side because I want to get rid of that radical sign, and the only way to do that is to square both sides. So that'll be my next step. Alright, so once I square both sides, I got rid of the radical. The plus or minus is gone, because when you square something, it doesn't matter if it was positive or negative. And I'm left with that foiled right-hand side of the problem there. So I'm going to keep going, simplify everything. I'm going to multiply by 2, made a couple mistakes, I had to erase them, and then move everything over to the same side. Alright, so pausing, luckily this is a problem that factors into 2 cosine x minus 1 and cosine x minus 1. Alright, so both of these we can find solutions for, and I'm good there. Now remember, since we squared both sides at the beginning, you are supposed to check your answers. So in the original problem, I would take sine x over 2 and put in pi over 3, so that would work out to be sine pi over 6 plus cosine pi over 3 minus 1. Hopefully this guy works out. Sine pi over 6 is a half. Oh. Cosine pi over 3 is a half. So that one checks out, we're okay. To check 5 pi over 3, I'm going to do the same thing. Put that back into the original problem. So sine 5 pi over 3 works out to be sine 5 pi over 6. Plus cosine 5 pi over 3. And we'll solve through. So sine 5 pi over 6, that gives us 1/2 again. Cosine 5 pi over 3, also 1/2, since it's in the fourth quadrant, and that one checks out. If we plug 0 back in, that's a quick check. Sine of 0 is 0. Cosine of 0 is 1. So we get 1 minus 1, which is 0, and we're good. So all these do check out.